Hi everyone, welcome back. So today I'm going to show you how to project vector data. There are two different types of data set, vector data and the raster data. Vector data means when we have some shape files like point, polygon, rectangle or polyline. So these are called vector data, right? These are not gridded data. So if we have any kind of data that is gridded like DEM data, we have the different types of resolution like 30 meter, 10 meter, or 100 meter, whatever the resolution of the data is, it has to be a raster. So we have to use the different projection system, right? If you want to project that raster data, we have to use different method. And if you want to project, like if you want to convert the projection system from WGS, means a geographic coordinate system, to UTM coordinate system, or even a state plane coordinate system, there are different types of, basically the UTM coordinate system. There are different types of coordinate system out there, so we can select based on our necessity. So each coordinate system, it has different merits and demerits. So now I'm going to show you how to project a vector data. So the watershed we have, these are the vector data set, because these are the shape files. So we need to even convert, because these are in geographic coordinate system WGS in 1983. So we'll convert it to US state plane coordinate system. So let me just quickly show you how to do that, right? That is very important, because if you want to convert the coordinate system, and you will use that frequently, so you have to know how to do that. And once you are done with that one, so you can do whatever you want to do. If you have different data set, both data may be different data set may be in different coordinate systems. So what do you have to do? You have to convert them to a single coordinate system. Then you can process, because if you want to calculate different values, you need to have the exact same coordinate system. So that's why this projection system is very important. So here it is. I'm going to create the new project from the beginning. So we have this one. So we are done with this lab one and the geodatabase we created. I'm done with that. I'm closing that one, and I'm creating a new geodatabase and project and everything. I'm gonna start from the beginning. So if I click there, or if you double click on your GIS, so here it is. I'm gonna create a new geodatabase as a different one. So I'm going back. There it is. Maybe, okay, let me, so there. Okay, here it is. And I'm gonna create now what? New one, geodatabase. So this time it will be lab 2, okay, or elevation, okay, lab 2. Okay, lab 2 is okay, because in the next tutorial I'll basically handle raster data. I'll show you how to download DEM data, and then we'll calculate different values like elevation, rainfall, and other calculation we'll do. We'll correct them. Okay, so we'll do that in the next tutorial. So lab 2, this will be lab 2 database. Basically I should follow the same name, 02. So we have that. I'm adding this one, okay, and that's it. And if I click OK, then I have a new one. It will be gone, and then it will open. Okay, it's still working. See, it's open a new window. Here it is. I don't need to create the layout view. So here it is. I'm gonna add my watershed that I have. I already have everything from the previous one, right? So here it is. We have the San Jacinto watershed. Basically that one I need, that watershed, right? So this one, so that is the watershed I have. Even if I want to add the sub watershed, as I can do that. Okay, whatever it is, I can calculate. So first I'll convert. So let me just check. If you right click there, how can you check which coordinate system I have right now? So right click, go to source, and then you can see, if you scroll down, you can see CGS, geographic coordinate system, North American 1983. What I will do, we'll convert it to state plane. Okay, that is the projected system. This is not the projected system, it is the curve. Since the surface of the earth is curved, so that's why this coordinate system is good for wide area, and the value will be a latitude, degree, minute, decimal degree. If you can change, see on the lower right corner, you can see when I'm just moving the cursor or pointer, you can see it is also changing. It is showing the longitude first and the latitude in decimal degrees. If you want to change the map display, how can I do that? Yeah, you can do that. You can just right click on the layer, you can open the properties, and you can go to the coordinate system, and you can change it. You can even do whatever you want. Okay, I'll show you time to time how to change the map view and the coordinate system, and you can select here, you can import, you can do everything, right? So that is the thing we need to know. We'll change everything. So let me just first show you how to project this shapefile or the vector data. So in order to do that, what I have to do, I have to click on Arc Toolbox, because whatever we are going to do, we have everything we can find it from that toolbox. And if you can't find anything, what you have to do, go to Customize and then Extensions, and maybe if you install for the first time, this may not be activated. So what you have to do, you have to activate all of them, and then you'll have there every processing we'll do in this tutorial. You can find this. So most of the time, what we'll use the data management tools. If you expand that, you have different options, and out of these options, we can see the projections and transformation, right? If I expand it, we have different options. We have even raster. So for projecting raster data, we have to use that format, but I'm not going to show you right now that one. When I'll download the DEM data, that is raster, I'll focus on that one. And at the same time, if I check here, and if there is no definition of the projection system, then I can define the projection system first, right? And then I can project it. So now I'm gonna project it using this toolbox and that data management tool, and then projection and transformation, and then project. Since it already has the projection system, and which one you are gonna project first. So I'm gonna project that sub watershed, okay? This one. I'm selecting that one, it is selecting, and then it will ask, okay, here, that is the input, and here it is already it's taken. See, the input coordinate system is there. If it is not defined there, so it will now show you unknown, but now I have that, and it's showing a default directory where we created. See, the first one, we have to change the geo database. It is there, lab 2, and it will be there. I'll change the name, but at first we can select the output coordinate system, okay? So which one will be our output coordinate system? Here you can see you can add the previous coordinate system as a favorite. We'll do that. And even you can select, if you have other layers, you don't have to find the coordinate system. You can just go back to layer. Since we have two layers, and each layer has the same coordinate system. So it's showing that one. If you have multiple layers, and if you want to convert one coordinate system to another, you need to know which coordinate system is there for other layer, and you want to make the coordinate system same, so you can find it there. Right, so this time we are gonna select from this one, projected coordinate system, and we have geographic. So since already the coordinate system is in geographic coordinate system, and we're gonna convert it from geographic to projected, so expand that one. And since we are gonna convert it to state plane, if you wanna convert it to UTM, so click UTM and find the zone, right, from WGS 984, and you can find your northern hemisphere or southern hemisphere, and you can find the UTM zone. If you know the zone number of your study area, then you can figure it out from this one, okay? You can find the zone number, and if it is south or north, you know I'll show you that later on, but now I'm gonna focus on only state plane, okay? So from that one, I'm expanding that state plane, and out of this state plane, because I have the basic datum as 1983, so I'll select the state plane that is related to that one. Let me find that. It is basically NAD in 1983. So these are all NAD 1983, and we have also 2011 international feet and 2011 meter. But what we'll select, NAD North American datum 1983 and 2011 and US feet. If I click that one, so it is giving you different options because it is within USA, and since it is changing, see, for Alaska, it is different. It has different unit, right? 3, 4, because it is for specific local area. If you project this watershed, we have to find that area that is for this Houston area, okay? So what is the number? Let me just find it out. It is just a straight plane, Texas South Central. It will be straight plane, Texas South Central, and 4204, because it is identifying that area. Straight plane, South Texas South Central, okay? We have the Texas here. You can see this is for Texas North Central, South Central, and 4204 US feet. If I select that one, you can see the properties of this false, sting false, and central meridian is minus 99 degree, and we have other information there. And if you want to add it to your favorite, you can click there. And if you want to, if you generate your own coordinate system, and you can import by clicking new or import, okay? And you can add it to favorite, so you can find it later on pretty quickly. So I'm selecting that coordinate system. Now it's there. Okay, and now I'm gonna save it where I want. So I'm gonna go back, inside that one. Okay, I can even that is lab 1. Okay, go back one directory, or let me just quickly make it clear that it will be there. Okay, inside the tutorial and lab 1, I'm going to create lab 2. I'm going to create new folder, lab 2, by that name, and inside that one I'll save every shape files, because I'll even download other data and I'll process this data, so it will be easy to access. That's why we need to have the same coordinate system, so that I can find it out where it is. So that's the way you can well organize your files and everything. So that will be like a watershed, right? So watershed, it is a state plane. I'm just using the name of the coordinate system because it is projected system, and it's giving you this name. And if you click OK, so it will start that projecting. Okay, that, yeah, it is converting the projection system from geographical coordinate system to state plane. So the horizontal unit would be in feet. So we are going to select that in feet, because we'll download the DEM data and we'll convert it to the same coordinate system. And then whatever we want to calculate, we can calculate that, and the value will be in feet, because in USA they just use that US customary unit called US customary unit. Okay, so the projection system, it's already done. Okay, it's already converted, and let me find it out. If it, see, you can't see anything there. You can't see. See, if I go to the property, which one I converted, this one or that one? Let me just quickly check that. See, it is there. And let me check if I have that, if it is already converted to that one or not. Go back. Okay, maybe I have. Okay, let me just add. See, I can't even add that folder connection. If I go to folder connection, I can access to anyone. Okay, but there is nothing. I have the E driver, and then I have to go to that one. Okay, so instead of doing that, what I can do, I can add that folder directly, so that I can get access directly. Okay, so connect to the folder. That is what you need to do, and navigate to that folder you want. Then later on, you will have direct access to that folder. Okay, now I added this one, that folder, and since we are going to work on that, so I'm adding only this one. Okay, and now I have this state plane. Okay, see, that is the new one, and that is different than one. If I open the properties, you can see it will be straight plane. Now it is no longer WGS 1983. It's straight plane, right? So this is how. So I'm just gonna delete that previous one. Okay, even I can. Okay, let me just quickly delete that one, and I'm gonna add that watershed first, and I need to even project that one as well. So here it is, watershed, right? Send just into watershed. Was that one? Yes. So let me just show you again, so that we'll have both boundary and the sub watershed as statement. So now I'm going to show you, if I already have the layer in different coordinate system, how can I find that one? So send just into watershed, this one. So it is showing the geographic coordinate system. So here I can find the coordinate system from my layer. Okay, now I'm going to click layer and see I already have that. If you expand that on, which layer is that? Watershed state plane. It is specifying this layer. So this layer has this coordinate system. I don't need to find that from that main tool. Okay, and since I already added that one, you can find the coordinate system even here, since I already clicked there. So this is the way you can even make a shortcut of your coordinate system. So if I add that, so that's why I'm showing it twice. Now I have that, and I'm gonna save it to there. So it will be like watershed. Okay, so only watershed. Send. Okay, send Jacinto watershed. Okay, so that's it. If I select, and it will also save there as well. It is also projecting, and I think it will be done pretty shortly. Okay, it's done, and it's showing messages on my other window. You can see that it's showing a green tick mark, and it's already added. If I delete this one, I don't need that one. Okay, so I already have that, it's there. And if I want to even open the properties, and you can see it is also there. And if I want to add, if I want to make it like as a boundary, make it hollow, and you can increase the outer boundary, and you can highlight it using any color you want, right? Any color you want, you can even do that, not a problem. You can highlight it using red, anyone. Okay, so that's the outer boundary. And if you want to do that, and if you want to make it hollow as well, and if you want to highlight these boundaries as well, you can do that way. And if you want to add base map, you can go to base map, and you can add the topography, you can add even that imagery, you can add different one, dark, National Geographic, terrain, anything you want. Okay, so yeah, I like to use that topographic. And if I add, now it will show, you'll see that where it is definitely Houston. You can see the Houston city there, Houston city, and it's covering the Houston city, and it is also connected to that Galveston Bay, because it is draining to the Galveston Bay, and Galveston Bay is connected to the Gulf of Mexico. Okay, so that's that. This is how we can project. And if you want to create a map, right, if you want to create, oh, it's not highlighting pretty well, I'm going to highlight that way. And if you want to even give the name, let me, okay, there we have the name. Let me check. Right, if I open the attribute table, you can see what we have. We don't have any name there, right? If you want to just show the number, we can add the name, whatever you want, you can do that. Means the labeling. If you go to labels and select the labels and Hawk10 name, we have that name, and you can increase the number, you can highlight it, you can change it to Time New Romans, right? And you can even apply, it will show you the number. It is not perfect, you can increase the number, you can apply and check, and that's it, right? This is how we can project. We already mentioned that one, right? How to create a map. So that's the way you can project. And in the next tutorial, I'll download DEM data, and I'll show you the link how to download DEM. That's the most important data we need for raster processing. So dealing with raster is easy. And after that, after processing all this thing, because these are the course, right? I'm just following the course material here, following step by step. And after finishing all this thing, I'll show, yeah, I'll try to give some tips. That is my tips from my experience, and that won't be any kind of organized way. Whatever I'll have in my mind, I'll have agilely show you. Okay, I'll show you each of these processes here. I have how to even make union or merge different data frame or different shape files, how to do this thing, how to do that thing, how to read netcdf file, how to generate like model builder, right, to process different calculations, how to even calculate raster calculation. You can operate, you can even calculate different types of raster value if you have different grids. For example, if you have a different temperature grid, if you have a relative humidity grid, right, your data, if you download data from NLDAS, you will have the data in a grid format. And what you are going to do, you can read the values from each of these grid, and you can calculate the relative humidity, right? That is what we need for running any HEC-SMS model. So I'll show you how to do that, and I'll make the automatic process. If you have many files, so do you need to even click and do that, click and do that? No, you can create a model. It's called model builder. I'll show you that, because already I have some videos on that one in HEC-SMS playlist. So I'll show you that, how to even develop that model builder. That will make your job automatic, because that is the Python script. So you don't need to write any script. You can just select the module, and you can add like by drawing and dragging. So that is pretty easy. So that is another way to even do an automatic thing. You can make your system automatic. So that's it. I'm going to finish off here, and you can just repeat all this process and let me know if you have any problem, because while projecting, definitely for the first time you may not be successful, right? Since I know all this processing and I'm just clicking right way. That's why I created the geo database first, and I'm storing everything there. If you have copied from one directory to another one, from one computer to another computer, it may not work. If you copy the folder, it won't work. For copying this file, we have specific direction, right? You can't even copy one folder and can't even open that from that folder. It won't work, because the GIS, it already linked with that specific folder. So for copying any folder, it is a better way to copy from that catalog. So I'll show in the previous, in the next tutorials after that, because we need to even copy from one folder to another one, the values, right? So if I calculate using our Windows Explorer, it won't work. We have to follow different rules and guidelines. So I'll show that. So by this time, it's okay. You can repeat and reproduce everything. If it won't work, let me know. Because I can help you on that. I can say, okay. So until then, stay safe and see you in the next tutorial.